All right, this lesson is about grammar of mathematics. Okay, what is the grammar of mathematics, right? The grammar of mathematics is actually very simple. First of all, it does not have past tense, okay? No past tense, no future tense. No could have, should have, would have, no, should have. Etc., etc. The only tense we have here is present tense. Only present tense. Only present tense, right? So when we talk about Pythagorean theorem, for example, that was discovered 2,000 years ago. And we don't use past tense, we use present tense because it is still true. So anything and everything we talk about in mathematics, we talk about the truths, either true or false. So that comes to what is the truth about mathematics? Truth in math. Okay, so any statement we state in mathematics, if it is true, it means always true. No exceptions. No exceptions. Okay, if we make a statement, right? Like we talk about the 6 mathematical principles, right? If you haven't watched that, please do. Those are mathematical truths, and those truths are always true. Always true. So what is a falsehood in math? False once, false. So any statement, you judge that statement, right? You say, okay, is it always true? Is this false once? If false once is false, it's thrown out of the thrown out of the window. Okay, so mathematical truth is judged that way. If true, it has to be always true. Of course, depend on your statement, right? But your statement can either be true or false. If true, it has to be always true. False once, false. Okay, so now that's about mathematical truth and the tenses, right? There's only present tense. The truth we talk about in mathematics, if true today, it should be true. Well, it is true yesterday or yesteryear. If true today, it's going to be true forever, for eternity. Right? Now, let's talk about the sentence structures. Okay, there are only 2 kinds of sentences in mathematics. Two kinds. Okay, one is a statement, and the other kind is if statement. Just these 2 kinds. 1, 2, there's no 3. Okay, there are only 2 kinds. Statement. Let's look at some examples of statements. Okay, so let's look at some examples of statement. For example, we say any number times 1 stay the same, right? We have that example. Any number times 1 stay the same. Any number times 1 stays the same. In shorthand notation, we have talked about this This is one of the mathematical principles, actually the first one. Any number is denoted by notation multiplied by 1, stay the same. That is a statement. That is a statement. Equal sign here means what? Equal sign here means the meaning of equal sign, right? The meaning of equal sign in this case means is the same as. Okay, so that's a statement. That is a statement. And of course, we can judge the statement true or false. For example, we can also say, it never rains in LA. That's a statement. It never rains in LA. Is it true or false? It's false, because you only have to point out one of the day, there's one day it rained in the record, right? So this is a false statement, false. And the mathematical statement, of course, can be false too. It can be false too, right? Now, so this is the one kind of statement. There's another kind of statement, okay? It could be m times x plus b. What does that mean? It's actually a statement, right? What does it say? It says, well, I'm taking a number m, and they will tell you what m is, right? M is described. X is also going to be described, right? X is another category of number, and plus B is another category number. Each symbol represents a category of a number, and this formula, which is a statement, it says, I'm going to take a number from the category of M, multiply another number in the category of X for X, right? Plus another number in the category of B. So this is actually a formula. Okay? This formula is also a statement. What kind of statement is this? This statement describes to us how the operation is done. It's a description of a process, okay? But you may also see this before. You say y equals to mx plus b. This is still a formula, but what does this say? This says, okay, you have that formula, right? A number m multiply x plus b, and we do the calculation and we get the answer, and we assign the answer to another quantity we call b. Assigned to. So in this case, equal sign, it still means the same as, but it also has a connotation of assignment. Assigning, okay? Assigning the number calculated by this formula to a quantity we call y. Okay, we're going to talk further about these kind of operations to you, okay? And next, another kind of statement, mathematics, right? Let's see if you guys remember, or if you don't remember, this will serve as a review. Okay, this will serve as a review. So we have these examples, right? We have these examples. Next, we will say a statement, okay? Ax squared plus b times x plus c. This is also a formula. And we're going to tell you what a is. For example, we're going to tell you, hey, a cannot be 0. A cannot be 0, right? That's a formula again. So this is a formula again. Formula again. You might have seen this before, right? And what else? And we will tell you A, B, C are what? Are real numbers. Okay? And we probably will tell X is related to something, etc., etc. And we can also do the assignment. We can also do the assignment. Okay, so we can assign this value to another quantity, Okay, and sometimes we call these output. Okay, but we're going to talk further about it. So the other kind of statement, we call it if statement. Okay, if statement. In comparison with if statement, all right, see these, right? Mx plus b is also called formula. There's another expression, another thing I want to bring that to you because you must have seen this. It's called expression. Okay, expression. And the next one is also expression. So expression is a statement. It's a description of how you calculate, or it's a formula. It's a formula. If statement, right? If statement. If statement, you typically see these wordings in, say, it will ask you to solve for X, for example. Solve for X, and they give you something, right? Say 2X minus 3 equals to 5. What does that mean? This is actually an if statement. This is actually an if statement. Okay, what is it? It says, if 2 times a number minus 3 is 5. Okay, find all the possible values of what? For X. For X. That's what it means. So solve for really is a if statement. It's an if statement. Okay. Another example of if statement. Okay, they may ask you to solve for X, right? This is, you typically see this. But this situation would be, I would have 2X minus 3 larger than 7. What does that mean? What does that mean? It is still an if statement. It means if, right? 2 times a number we don't know, 2 times a number we don't know, and minus 3, okay, is larger than 7. Larger than 7. And then you find all possible values for X. So these are the situations of if statement. So you can see in mathematical context, right? You either have a statement which could come in different kinds of, different formula or different form and shapes, right? But they're just statement. They can be true, can be false, or if statement. If statement, it comes for, in our case, you have heard this is called equation. All the equations are if statements. All the equations are if statements. Okay, and the statements are also called expression. So you must have learned this before. So there are only two kinds of statements, two kinds of sentences, in mathematics. So when we look at these mathematical expressions and equations, they all fall into either it's a statement or if statement. There's no other form. There's no other form. Okay, so this is the introduction to grammar in mathematics. And of course, we have lots of vocabularies, right? So that's what we're going to build throughout the semester or review. But in terms of the grammar of mathematics, so let's summarize: no past tenses, no future tenses. So maybe I should put plural here. Only present tense. And we're talking about truths. Okay, any mathematical truth we get today is true forever. True forever. Okay, so the criteria for mathematical truth is that it has to be always true. False one's false. False one's false. That's all for this lesson. Thank you for listening. Thank you for watching.